Hi there. How do we simplify these complex numbers? We'll use these two relationships, these two equations. I squared is equal to minus 1 and I raised to the minus 1 is equal to minus I. So how do we simplify I to the 7th? Using indices, we can write this as I to the 4th times I to the 3rd. I to the 4th is 1 and I cube is the same as I squared times I. And this I squared is negative 1 times I, which gives us minus I. Next we have I to the minus 3. Well, we know I to the minus 1 is minus 1, so we can write that I to the minus 3 is the same as I to the minus 1 cubed. Now if we replace I to the minus 1 with minus I, we have minus I cubed, which is the same as minus I times minus I times minus I. Now I squared is minus 1, and this times this will give us minus 1. So we have minus 1 is equal to minus 1 times minus I, which is equal to I. Next we have I raised to the 9th power. Using indices, we can write this as I to the 4th times I to the 4th times I. I to the 4th is 1, so this is times 1 times I, which is simply I. Remember, in indices we add, providing the base is the same for each. We add the indices. 4 add 4, and this index is 1, will give us I to the 9th. Next we have I to the minus 5. Well, we've just done I to the minus 3, so we can write that I to the minus 5 is I to the minus 1 raised to the 5th power, which gives us minus I to the 5th which is equal to, so we know that I to the minus 1 is minus I, so we can write this as minus I raised to the 5th power, which is the same as minus I to the 4th times minus I, which gives us 1 times 1 times minus I. So if we split minus I to the 4th into minus I to the squared times minus I squared, which gives us 1 in both cases. And this, let me just got off the screen there, I'm sorry. Let's just write it minus I squared times, we don't have to put the multiplication sign, minus I squared times minus I. And this gives us 1 times 1 times minus I, with a result of minus I. I squared is minus 1, and minus 1 times minus 1 is 1. And so we get that for this and this term, which multiplies to give us minus I. I to the 4n we can write as I raised to the, oops, let's write that in the brackets, I raised to the 4th power, and that's raised to n. I to the 4th power is 1, so I raised to the power of n. N being a natural number will always give us I. So, my mistake. I to the 4th is 1 raised to the n. So, n being a natural number, this result will always be 1. Next we have I raised to 4n add 1, which can be written as I to the 4n times I raised to 1. We know I to the 4n is 1, and I to the 1 is I, which gives us I. So there you are. We've simplified these complex numbers by just using these two equations. I squared equal to minus 1, and I raised to the minus 1 is equal to negative I. Thanks for watching. I'm Alistair. Hi, how do we go about simplifying this expression? Bear in mind these are complex numbers, so it has an imaginary part y and a real part x. In this case it has an imaginary part minus y and a real part x. We'll clear the brackets just as we will normally do in any algebraic expression like this, and this will give us x squared minus x y I add x y I minus y I squared. This, when simplified, this cancels with this to give us minus y squared, and we have I squared, which is minus 1, which leaves us with x squared add y squared. Remembering complex numbers, we have that I squared is equal to minus 1, and that's based on the fact that I is equal to the square root of minus 1. So if we square both sides, we have I squared, and if we square the right hand side here, we'll have minus 1. What about this one? So we can write this as 1 add I squared times 1 add I. So we'll try and expand this, which 1 add I times 1 add I, and then we have 1 add I here. So this will give us 1 add I, add I, add I squared, and we'll leave this as it is for now. And if we simplify this, we have this is I squared is minus 1, and that will cancel with this one, and we're just left with 2i. Now it's 2i into 1 add I, which gives us 2i add 2i squared, I squared is minus 1. So we write minus 2 add 2i. The real part must be mentioned first, followed by the imaginary part. Thanks for watching. I'm Alistair. Here we have two complex numbers and we'd like to add them. We'll add the real parts. So we'll put together 2 add 4 in brackets and add it to the imaginary part, which simply gives us 6 minus 2i. The real part is 6, imaginary part is negative 2. Here we have something a bit more abstract. We have the real part, a add c, and then we have bi add di. We can write this, the real part is a add c, and the imaginary part is b add d. Thanks for watching. I'm Alistair. How do we simplify this complex number? A add bi squared, which means we have a add bi multiplied by a add bi. Gives us a squared add 2ab. Now we have b squared times I squared. This leaves us with a squared. This will give us minus b squared. So we write that next to this. We're adding this to 2abi. The real part added to the imaginary part to give us a complex number. How do we go about clearing the brackets here? Well, we'll multiply here by I to give us I add minus, I squared, and that's multiplied by 2 add I. The I squared is negative 1, so we have more I minus 1 times 2 add I. Now we can go ahead and clear the brackets. Gives us 2i add I squared minus 2 minus I. If we gather the imaginary number or parts and the real parts, we have negative 2 here, and this becomes a real because it's now negative 1. So we have negative 3 as a real part. This is added to 2i, take away I, which gives us I. There you have it, a complex number. One real number, negative 3, added to the imaginary parts. Actually, it's 1 and not I. Thanks for watching. I'm Alistair. Hi, what about division of complex numbers? Well, direct division is not possible since the denominator consists of two independent terms. One would be the real term and the imaginary term. So what we do is we make the denominator real, and let's just call it realizing the denominator. So here's an example. 3 add 8i divided by 5 minus 3i. And here we'll use the product property of conjugate complex numbers, which you'll come across sometime in algebra. Here we'll multiply the numerator by the conjugate, the complex conjugate of this denominator here. So this would be 5 add 3i. And then we'll multiply the denominator by its conjugate, 5 add 3i. So we'll clear brackets in the usual way. 15 add 9i add 40i add 24i squared. And this denominator is 5 squared, which is 25 minus 3i squared. So I've put the brackets, make sure you don't forget that it's both the 3 and the I to be squared. Now, if we simplify the denominator, we have 15 add 49i minus, so this is 24i squared. I squared is minus 1, so this is minus 24. And in the denominator, we have 25 this is 3 is 9, I squared is negative 1, so it's minus 9 here, which gives us add 9. I'm off the board here. We rewrite that. So in the numerator we have 15 add 49i minus 24, and in the denominator we have 25 add 9, and this gives us minus 9 over 25 added to 40, no, not 25, 34 and 49i over 34. Rewrite that. Minus 9 over 34 added to 49i over 34. Just to recap what we've done, we've just multiplied the numerator and the denominator by the conjugate, the complex conjugate of the denominator here. We clear the brackets in the usual way, being aware that I squared is negative 1, and we simplify to have the real part. Even though it's negative, we still write it first, imaginary part, 49 over 34. I'm Alistair, thanks for watching.